Hi guys, we're going to do the baking soda lab, and what I want you to do is I want you to write down a set of procedures for yourself to follow during the actual lab. Before you even do that though, you should just get yourself some loose leaf, put your name on it. At the very top, write down the baking soda lab, because that's the title of it, and you can date the page. Later you'll be able to transfer this to your archive by taking a picture, but right now I want you to do it on paper. So go ahead and pause this while you get loose leaf, write your name, write baking soda lab and the date, and then go ahead with the rest of this. Okay, hopefully you've done that, and I'm going to actually not use baking soda for my demonstration of the baking soda lab, and that's because I don't want to ruin the surprise. Instead of baking soda, I'm going to use copper sulfate, which is that blue powder that makes the pretty blue liquid. So in order to do this lab, first you have to set up all of this equipment. You get what I call about a ½ centimeter's worth of your powder. In your case, it's going to be baking soda. In my case, it's going to be copper sulfate. And the whole point of this lab, and you should write this down before you even write down your procedures, you can write down the whole point of this lab, the purpose or the objective of the lab, is to answer this question. When I heat this substance, in your case it's going to be baking soda, so when you heat baking soda, does it go through a chemical or a physical change? So you need to write that down, so I would recommend pausing. When you heat baking soda, does it go through a chemical or a physical change? I'm going to heat copper sulfate and see whether it goes through a chemical or a physical change. And that's because I don't want to give away the surprise with the baking soda. Now I could just heat my copper sulfate in this test tube and put it in a clamp and put it under a fire stand, over a fire stand, and just start heating it. But if I do that, if it does go through a chemical change, I might miss some information. Like, for example, if it turns to a gas. So what I want to do is I want to create a gas trap. You'll remember we did this with a balloon in our previous experiments. When I had you do the Alka-Seltzer in the water, I said put a balloon over it, see if you get a gas. We could do that. We could just put a balloon over it, and that would tell us whether or not we get a gas. However, balloons are not able to capture as much gas as a gas trap, and that's why I want to switch to using a gas trap. That's what I have here. This is just an empty bottle, water bottle, that's filled all the way up with water and then inverted into a tub that's half full of water. So you just take an ordinary tub, one of my ordinary tubs, make sure it's not one of the ones with a crack in the bottom. Go ahead and fill it halfway. It's important that you not overfill. You want to keep it halfway, because if you go much higher than that, you'll get overflow later. Then you want to take a regular water bottle, fill it all the way up. It has to have a lid for this. Fill it all the way up to the top. Try not to leave any air spaces. And then if this is full of water, you can just turn this upside down, unscrew the cap while the cap is underwater, and then the water will stay in there. And that's what I've done here. So this is a totally full of water bottle that's inverted into a half a tub of water. And you also notice I have some rubber bands here. And those rubber bands I put on before I began. So before I filled the tub with water or filled the container with water, I stretched the rubber bands and I made them go one in each direction. And that makes a nice way to hold this down. Because if this container does fill with gas, it becomes lighter and lighter and lighter, and then it starts to float, and then it doesn't want to stay put, and then you run into problems. So this will sort of hopefully keep your gas trap safe and secure. The next piece you need to make a gas trap is you need a gas trap apparatus. The word apparatus, just a fancy word for equipment. It's 3 pieces of equipment. It's a rubber stopper right here that has a hole in it that I put a piece of glass bend through, and then the other end has another piece of tubing called the delivery tube. So those 3 pieces together then fit into your large test tube up here. And then this delivery tube can then be snaked up into your gas trap. You have to be careful here. You don't want to release any of the water from your gas trap. You just want to snake it in as far as it'll go. And now you can see that if a gas is created in here, if we get a gas being created in here, it will go up this tube into this other tube and then into the gas trap. And it takes a while for gases to dissolve in water. So most gases, when they first get in there, will just float up to the top of the bottle and hang out there. If you let it sit overnight, that gas might dissolve into that water, but usually if you do it fast enough, you wind up with the gas trapped in your bottle. So that's the idea behind this. So we want to see if we're going to get a gas, because if a gas is created, that's an indication of a change. But whether it's a chemical change or a physical change is going to depend on whether or not the substance goes back to being a solid again later. Because I could just heat this up, melt it, and then turn it to a gas, right? If I had water in here and it was let's say it was a frozen tube of water, and I heated it, that water would melt, and then it would turn to a gas, and all of that gas would go in here, and as it cooled down, it would turn back to a liquid, and then if I put it in the freezer, it would turn back to a solid, but it wouldn't be a new substance. So just because you get a gas does not automatically mean that you have a chemical change, though it could be a piece of evidence in your favor for chemical change. So what you're going to do is, once you have that all set up, you want to make sure that you have a second test tube with your substance in it that's identical to the first. This is your control test tube. So for you, you won't have two blue powders, you'll have two white ones, because you're going to have two tubes with baking soda, and they should be the same amount in both. And you should actually measure that out. It doesn't matter how much, but you should actually get one of the electronic balances and get the mass of that stuff, so you know you have the same amount in both test tubes. It doesn't matter how much, it's roughly this amount, and you should make sure that you put the same amount in both test tubes. You're just going to put that aside for later. Now you're going to go ahead and light your match, and when you do that, goggles on, hair tied back, and then you're going to let that go for 10 minutes. After that experiment is done, you'll see already, you can see bubbling in the gas trap, right? Now here's the thing though, you're going to see gas forming in your gas trap no matter what, because there's gas in this tube, there's air, and that air will expand when it gets hot. So you'll always get some just plain air coming out. So you really don't want to say, oh, I'm definitely have a gas being created, until you think that you've gotten all the air out of your test tube. And that you have to sort of estimate how much air is in that test tube. Well, it's about as much as the test tube would hold, which is, these are 25 milliliter test tubes. So once you get about 25 milliliters of gas in here, that's when you know, okay, all the air is out of the test tube. Now, you're kind of far away on the camera, but I'm watching this test tube, and I'm starting to see two things happen. I don't know if you can see this, but you see the fog forming here? It's on the inside of the test tube. I'm getting a fog. And I'm also getting a change in color of my copper sulfate, which is very hard to see on camera, but it's kind of turning whitish, which is interesting. After 10 minutes of doing this, I will actually have about enough gas to fill just like about this much of my gas trap. This will be totally white, the powder, and I will have some kind of fog up here, and I'll even start to see and hear little droplets that look like water. I don't have any evidence that they are water, but it looks like water. There are lots of clear, colorless liquids that you could be creating, including acids, but it's safe to assume that this liquid has a good chance of being water. Kind of depends. And you can see it really getting foggy and getting actual drops of water in here now. So I'm not going to let this go for a full 10 minutes, but I want to show you something that you're going to need to do. You're going to need to, at some point, after your 10 minutes of heating your baking soda is over, you're going to need to remove the heat. But you want to be careful here, because remember, with the kinetic theory, once I remove the flame from here, the particles of gas that are in this test tube are going to suddenly cool off. And when they cool off, they're going to come close together. And when they come close together, I'm going to create a partial vacuum inside of here. And what do vacuums do? They suck. So the vacuum will actually suck up water from here and draw it into there, and that ruins your experiment. So you don't want that to happen. So it's very, very, very important that you remove this tube before you blow out your burner. And you also want to be careful when you're doing this that everything is really secure, because you can't touch this stuff, right? It's really, really hot. So if it starts moving around on you, you've got to stop and call me over, because you're not going to want to try and catch that with your bare hands. So you might as well call me over and let me deal with that. So take this completely out. You'll see you'll get some water dripping out there, right? Kind of shake it out. And now, you see how I didn't put it into the tub. I put it down on the table. And you'll get some dripping. Now it's safe to pick up your alcohol burner and blow it out. And then you're supposed to let that cool. As soon as you can, you want to try and remove this if it's not too hot. If you want help from me, you can. Now, I didn't let it go a full 10 minutes, so it hasn't completed the reaction. But after 10 minutes, this would be totally white, and most of this liquid would be gone. Your next step